One of the big environmental issues with surface water is pollution. And we can think about pollution in terms of its residence time. Residence time can refer to just the time a water molecule is in the reservoir, or it can be how long is a pollution in the reservoir. For a river, we can expect pollution depending on the nature of the pollutant. Sometimes they can sink to the bed of the river and stay there, but in general, if it moves along in the system, pollution can be in a river system at a certain spot for 2 weeks. A lake, it might be more like 50 years. Groundwater, we could look at it at hundreds or thousands of years unless there's some kind of intervention that pulls out that pollutant. Glaciers, a whole different story. We don't think of them as polluting them, but the ice can be millions of years old in a glacier. Let's look at some of the different pollutants that can get in surface water. The first we're going to look at is oil. And normally oil is accidentally spilled into surface water, usually the ocean. And it's an accident with a tanker or at a pump or at the drilling site. It also can be done kind of maliciously. The military can activity can cause a spill, or the military has special rights that they can flush out systems and pollute with oil. So the military activity also causes oil pollution. The problem with oil is the organism. So it coats and kills animals, and it can disrupt the normal ecosystem. Like if it kills the plants, then the turtles don't have anything to eat. And if the turtles die, then the whales don't have turtles to eat. So just kind of that whole food chain, food web can collapse because of it. We just had the anniversary of the Exxon Valdez in the last week or two or so. In 1989, just as I was getting ready to graduate high school, there was a tanker that was moving through a bay in Alaska, and it was unescorted. It was dark night. The ship's captain was drunk. Someone else was piloting the ship, and it ran into rocks. And in that area, they had no containment booms that they put out there to contain the oil. They had nothing to function to ready to clean it up. So it got worse and worse and worse until they were able to bring in machinery and materials and people to clean it up. So since 1989, that event, a lot has changed with the readiness of these areas where they know there's going to be oil shipping in and out. Especially with Valdez now, that area, they have to have like almost like a tugboat escort them in the narrow passageway to get to the coast. In 2010, you may remember, there was the oil well blowout where they were drilling in the Gulf of Mexico, and they hit like a oil under pressure and exploded, and people died in that event. I can't remember how many, maybe 30. It's just kind of a guess. And there was a big rumor, or not rumor, prediction that all the seas were going to die because there was so much oil being lost into the Gulf of Mexico, and it was swirling around. They're still getting over that in that area with the economy, and the beaches kind of took a hit, and the tourism took a hit in that area. There's a little video there. Click on that back in the stagnant PowerPoint and learn a little bit more about the Deepwater Horizon movie. So oil slicks, there's pollution. This is sediment pollution coming in. So sediment, I have a dog running out again. Okay. Sediment. We learned about soil and how it is a resource, but it also can degrade water supplies. the measure of suspended solids in our waterways is called turbidity. And turbidity is not good for fish. It's not good for mussels, clams, the corals of the ocean, none of that, because of how they get oxygen out of, dissolved oxygen out of the water. And so if they're breathing in sediment and can choke them and they die. So sediment is a pollution. Usually the sediment we're talking about that is a pollution is the fine grained sediment. So like a pebble, not necessarily a pollutant, as is clays and silts are more of a pollutant. And where does it come from? It comes from runoff. And it comes from runoff from agriculture, any deforestation, forest fires, construction, logging, any of that. And I'm asking here, what do these have in common? What do agriculture, construction, and logging all have in common? Right. You have a loss of vegetation, that cover that's holding the topsoil in place. So when rain falls on that and it washes it down to our river systems. When that happens, our rivers can get choked with sediment. And that choking of sediment can shift the equilibrium of a stream, right? If you have sediment input into the stream, it's going to change the gradient of the stream, maybe make it steeper. If the stream channel gradient gets steeper, then you're going to increase the velocity and the erosive power of that stream. So you have that erosive power, then it's going to erode more sediment downstream. So it's a positive feedback loop in not a good way. So it's going to cause more erosion downstream. I show in this image here, we have livestock trampling the streams. In some places, that's illegal. In some places, you can't let your livestock just go down to the waterways. You'll see fences right along the river. Just depends on the laws of that area. All right, here's some cooling stacks. So thermal pollution. Thermal pollution occurs when we've unnaturally heated surface waters, the artificial heating of the surface water. And usually this is because of industrial operations or a power plant, perhaps. So in a power plant situation, you're generating electricity because there's heat, then you've got to dissipate that heat. So having it water supply like a river, they would pull the water off the river, cool their system, and then put that water back in line in the system, and it's hot now because it cooled off that area. So some organisms are temperature specific species, and the temperature change in that ecosystem then it can kill those species. Like a trout, for example, can't handle like the pulses of hot water. One way that industry or power plants have gotten around this is using that heat maybe to heat buildings. So send it through the radiators in your factory or use it to heat office space so they can radiate out that heat from that water like a radiator in your house would do. Thermal pollution occurs in Boone when we have hot surfaces in the summertime in Boone. And rain falls down onto those hot surfaces like asphalt, black surfaces, and it heats up. There's a measured increase in the temperature of Boone Creek after rainfall events in Boone in the summertime because of that hot pavement. The water hits it and it goes down into Boone Creek and elevates the temperature. So there's a pulse of thermal pollution every time it rains in summertime in Boone. Nutrients. Okay, so let me move my face here. Let me get rid of my face. Fertilizer has nitrogen, phosphorus in it, and when those wash into our waterways, maybe from agriculture, as well as detergents that have phosphates in them. These days, a lot of detergents are phosphate free. They actually don't work as well, but they are phosphate free because of this. Sewage treatment plants also are generating like water and sludge that essentially is a fertilizer. So when those go into our waterways, we have something called cultural eutrophication. And eutrophication, that word eutrophic means well fed. So the water now is well fed with nutrients. those nutrients then that are washed into the waterways increase the plants. Mostly it's going to be algae, like this slimy mess here, something like you'd see on a golf course. So here's a water treatment facility. Here's a bunch of fertilizers, say you might like see at Lowe's Hardware. And here's what it looks like in a pond that has too much fertilizer, whatever it is, washing into those nutrients, washing into the system. So the algae then grows, it blocks the sunlight. It's total blocking the sunlight down below. Everything starts to decompose, and the decomposers of all those dead plants is what leads to the high BOD, which is a biological oxygen demand. Here's some pigs, because boy howdy, they poop. All right, oxygen demanding waste. Let me turn myself back on here. Me on? So I mentioned BOD, that here's that BOD right here, the biological oxygen demand, biochemical oxygen demand. So the oxygen demanding waste is going to be the dead stuff, organic matter, leaves, sewage, the algae from the nutrients, whatever it is that's in the water, and the bacteria goes to decompose that the vegetation, leaves, sewage, algae, and the water then becomes depleted of dissolved oxygen. So when we try to figure out the health of water, we can put a little sensor down in the water and measure the dissolved oxygen. If that dissolved oxygen is low, then the fish and other organisms essentially suffocate because there's no oxygen in the water. So we have poor surface water health. It's low DO, but BOD would be high. That's the oxygen demanding waste, and we can measure that. There's an equation. You have to have 5 days of measurements at 20 degrees Celsius. It's milligrams per liter of oxygen consumed in that time at that temperature gives us a value of BOD. So high BOD means there's lots of dead matter and low dissolved oxygen. This happens from time to time in North Carolina. The Neuse River runs through agricultural land that they spray with hog waste. And if there's a rainstorm too close to when they spray the hog waste, they'll get these die-offs. So there's images like this one here, where the fish have died because they've suffocated. And this is also, you hear about dead zones in the ocean, like off of the Mississippi Delta. There'll be agricultural waste washes into the sea, and they'll get a dead zone because of the lack of oxygen. So the ocean gets these as well. All right, these are some scary little buggers. Pathogenic organisms. Pathogenic means it causes a disease, and they're usually going to be little, right? A microorganism. And they're really small, and you need a microscope to view them, so you may not know that you're ingesting this pathogenic organism. And there are different organisms, so those that are bacteria and those are viruses. So bacteria can cause like cholera or typhoid, whereas a virus would be like hepatitis. Dysentery also is a bacterial pathogen. The way we measure for these is by measuring the human fecal coliform bacteria. That's kind of the standard. So if we can, that's what we measure to say there might be these other organisms in there. Because all of your poop has this fecal coliform bacteria, so and these other bacteria and viruses would also come through sewage. So measuring the fecal coliform is the baseline for, okay, that's in there, then let's measure these other pathogenic organisms. So human waste is kind of the standard. So why would we do that? Because they're going to cause death and illness. It's not safe for us to have fecal coliform in our bodies other than in our poop, our digestion. So we don't want that. Okay. In the United States, it's not really that big of a problem. There are scares from time to time of different things like don't eat the lettuce or don't eat the bean sprouts, whatever it is, and they usually can track it to a certain incident or farm or restaurant. because we do a pretty good job of keeping our drinking water separate from our sewers. And where the line is sometimes crossed is in countries that don't have the infrastructure to do that, or during a natural disaster. So earthquakes, floods, of course, where water's getting all mixed together, hurricanes, tsunamis, anytime where you breach a system and can contaminate another system is where you may get these outbreaks. And that certainly happens, usually not in the United States, but in other countries because of a natural disaster. In 1993, in Wisconsin, there was a cryptosporidosis parasite. So what happens is they try to bleach away the parasites. It will kill them, and sometimes there's a resistant one, so that will happen. And it happened in 1993 in Wisconsin. The last pollutant here is toxic substances. A toxic substance is going to be anything that's bad for organisms, so bad for humans, bad for the ecosystem. There are different kinds. We can look at hazardous chemicals, any kind of synthetic, organic material or inorganic compound that's not good for organisms. Another one is, and so that might be easy to detect, those hazardous chemicals. Maybe they smell bad, or we can see them, or we know they got into the system. One of the ones that's kind of a silent thing that's harder to realize with these heavy metals, whether it's lead, mercury, cadmium, arsenic, zinc, those are usually going to be washed in some way that's maybe a small, seems like a small amount, but over time they'll accumulate in placer deposits. And if something stirs up that placer deposit, placer would be like where it's deposited by its weight, almost like panning for gold. It'll just get into like a little nook, like and accumulate over time. So if you disturb that sediment, then it gets into the ecosystem. And these are usually going to bioaccumulate. So if the, say, arsenic gets into the plankton, and then a fish eats the plankton, and the bigger fish eats that plankton, and it goes up the food chain till the big top of the food chain organisms like sharks, polar bears, humans, grizzly bears, tigers. Those are the organisms that have an accumulation of the heavy metals in their cells. So that's why, you say you wouldn't eat a lot of king mackerel. That's kind of a fish that has an accumulation of heavy metals in it. So yeah, they can, if it's heavy metals in the floodplain, it can get pulled up into plants and cause neurological disorders with the organisms. It's like your mom being scared of you eating lead paint. These days, all little kids are tested for lead, no matter where you are, just to make sure you're not getting lead paint. The last one is radioactive minerals. Radioactive minerals, they're natural in the environment. So rocks, granitic rocks, have radioactive elements in them. That's one that does. And it can get in water. So you can test your water for like radon that you may think of being in a basement. They can also test for it in your water. So toxic substances are bad. Acid mine drainage. So here is that orange water is kind of a hematite or maybe some sulfur that's getting deposited. Acid mine drainage occurs when. Me and Brad watch them go together. Okay, I'm almost done. Usually it's going to be a sulfuric acid, so it's the oxidation of minerals like pyrite, sulfide minerals, pyrite, and oxygen-rich water are going to oxidize and form sulfuric acid. It pollutes the surface water and the groundwater. It's acidic water is toxic to plants and animals. There's significant places. There's a list there of all the states where there is acid mine drainage. And we're constantly working on this. People find it and report it, and it's got to get cleaned up. And they find it, report it, get it cleaned up. So attempts are made really to isolate those tailings piles and maybe submerge them in water or move them somewhere away from a waterway just to get them away from surface water. That's harder to do with groundwater, but they try. Okay, the end of the slideshow.